All right. So this is actually going to be live right now. And we're going to be going through the chapter 4 of my chemistry class's study guide. We're going through it live. So let's go ahead and let's get started. So chapter 4 study guide. Reminder, the test is tomorrow. So we'll probably take about half hour, 45 minutes here, hopefully, and get this going. So give me a quick second. So, number 1 here. Says Greek philosophers thought matter was composed of 4 elements: air, earth, fire, and water. That is true. They did not know any better. That's what it was. Next one. In the notation in that picture, it says 107 represents the atomic number and 47 represents the atomic mass of silver. That is false. So the mass number is 107. 47 is the atomic number. So this is just what we're going to kind of be talking about for now. Radon. It's a radioactive substance that undergoes spontaneous emission of radiation due to unstable nuclei. That is false. All right. So once again, as a reminder, this is currently live. This is not pre-recorded. So number 4, atoms of a radioactive element. They can change into atoms of another element by emitting radiation. That is true. All right, next one. Proton is a subatomic particle carrying the equal to but opposite charge of an electron. That is true. Proton has a charge of 1 plus. Electrons have a charge of 1 negative. Then it says number 6, cathode rays are deflected towards a negatively charged plate in an electric field. That is false. Cathode rays are negatively charged particles that emerge from a discharged tube. So, for those of you watching right now, I'll say it again. This is actually currently live. This is the chemistry chapter 4 study guide. Yeah. For those of you who may not know, all right, next. 7. An industrially important element contains 26 electrons and rusts in the presence of air and moisture. So identify the element. So by knowing the fact that we have 26 electrons, that would tell us that we also have 26 protons, because the number of electrons is equal to the number of protons, which is equal to the number of, well, it's the atomic number. So at that point in time, our element would be choice B, which is iron. That's right, Sauce Boss. Yeah. All right, number 8. What is the mass constant of a proton? Mass constant of a proton is B, 1.007. Then obviously 276 AMUs. So here I'm just going to kind of get through these. Matter was composed of tiny indivisible particles, was originally given by old Democritus. Number 10, researchers discovered a subatomic particle while working with cathode ray tubes. That was an electron. All right, what is a subatomic particle that has mass nearly equal to that of a proton, but does not carry an electrical charge? So that would be a neutron. That should be self-explanatory. It's neutral, so it has no charge. All right, so now let's pop back up here. Atoms with the same number of protons but different numbers of neutrons called what? They are isotopes. Uh, 13. Uranium is a naturally occurring element that emits particles and rays spontaneously through a process called what? That is radioactivity. Let's make sure I spell that right. All right. Radiation. I had a question about that today in class. Radiation is not the correct answer here. Radiation is what's given off. The process of emitting radiation is radioactivity. All right, for number 14. An alpha particle is blank charged with 2 protons and neutrons. You should have positively. So next, kind of scroll here. Number 15, a beta particle consists of a fast-moving electron and has a what type of charge? Negative. So basically what happens here is an electron has a 1 negative charge, so that means your beta particle would also have a negative charge. In nanotech, individual atoms are used to see... Individual atoms are seen using the what microscope? That would be the scanning tunneling. 1L. Make sure I spell stuff right. Next. 17. The mass of an electron is what? 9.1 times 10 to the negative 28th grams. You could have that or 9.11 times 10 to the negative 28th. Either one, I'll accept. Not exactly gonna be a stickler there. So next, number 18, old James Chadwick. What did he show? He showed that the nucleus also contained a neutral subatomic particle known as the what? Well, neutral should have been your hint. It is the neutron. Then next, Democritus believed that matter is made up of tiny individual particles known as what? Two answers are acceptable here. You could write atomos or atoms. Either one's acceptable. Then you have number 20 here. The number of protons in an atom is called the blank of the element. So the protons is called the atomic number. Nuber? Let's scratch that out. How about that one? So, there's nothing that can really be more explained with those. Those are kind of facts and statements. So, let's go to the short answer here. We'll talk about it. So, 21 is just a definition of an atom. I mean, that's the smallest particle of an element that retains the properties of that element. So I'll write out the definition that would be acceptable here. I gotta make sure all this is still on the screen. That retains the properties of the element. All right. So 22. What this is, the atomic mass unit basically measures the mass of an atom relative to that of a carbon atom. It's generally seen as 1/12 of the mass of a carbon-12 atom. So I'm not going to write that out. Actually, yeah, I will. All right, so 1/12 of the mass of a carbon-12 atom is, well, 1. All right, number 23. Make sure this is still on the screen. It is. So, what is a nuclear reaction? Simply, it is a reaction that involves a change in the nucleus of an atom. So basically, it can change one element into an atom of another element. I kind of one element. Forgot to write the E there. Changing an atom of one element into an atom of another element. Oh, starting to just miss letters here. Okay. So basically, so far, all of this stuff has been definitions. The first thing that hasn't been a definition is number 24. So, here we go. 24 says, how are atomic number and mass number denoted in the chemical symbol of the isotope of an element? Express the shortened notation for an isotope of element X with atomic number 92 and atomic mass 238. For this one, all I'm going to require that you do is just write the notation. All you have to do is write the notation of it. So the notation is the atomic mass over the atomic number with the symbol beside it. So I'm going to move the camera a little bit. Let's see if I can write this small enough. Okay, so that's the general layout of this. Now, how do we put what's in our problem over here? This is what we're given. So how do we put that into this notation? So we're given the atomic mass of 238. So 238 here. Then we have atomic number below it. So that's 92. Well, it is live now, so my bad. I'm kind of losing some light. There we go. And the element symbol. Our element symbol in this question is X. So that's your answer. That's number 24. So, any questions so far? Any questions at all? I'll give you a minute to figure out if you have anything. Is that a yeah, you have questions, or we're good. I wasn't going to, but then I actually ran out of time to record it or pre-record it. So here we are. So, Maisie, you good? You've missed half of it and you're at rapid fired. All right, well, we'll move on. So, I shouldn't have eaten ice cream right before this. Continuing on with chapter 4. We are now on to number 25. What are the main flaws in Dalton's atomic theory? His flaws, so kind of have two of them. Atoms are not indivisible. We know that they are because, well, there's protons, neutrons, electrons, and even further down than that, there are quarks. And then the second main flaw, basically all atoms of an element, they don't have identical properties. We know that they all do have the same chemical properties. Ooh, I just ran out of ink here. I hope not. So that's the second main flaw here. All right, number 26. How are electrons held within the atom? They're moving really fast through all the empty space around the nucleus. So, how are they held? Electrons are negatively charged. Protons are positively charged. Opposites attract. So, they are held together or held together so that's not going to be enough. What we also have to say here is the fact that protons are positive. Oh, I probably need to zoom back out here. Protons are positive and electrons are negative. All right. So that's that. So next. All right. So what I'm going to do, I'm actually going to fill in on study guide. fill in on study guide on the screen. So let's talk about this. Actually, I need to write some stuff as well. So when we're given all of this information, we have these 5 things across the top of the chart. You're given number of protons right there, number of electrons, number of neutrons, atomic number, and mass number. A lot of these things can relate to each other and are equal to each other. So what we're going to do, I'm going to tell you what is equal to what, and we'll get started here. So when we're given atomic number, that is equal to the number of protons. In fact, that is the number of protons. That's the atomic number. And then the number of protons is equal to number of electrons. All right. So we have that fact. I'll zoom out a little bit more. Looks like I gotta do a little more. That's better. Then we have that number of neutrons thing. So how do we calculate that? Well, you have your mass number. And that is equal to the number of protons and number of neutrons. Equal to the number of protons and number of neutrons added together. That is your mass number. So what I'm going to do, let's see, change text color to bright red. So with sodium here, we're given number of electrons, so we know the number of protons as 11. Since we know that as well, we know the atomic number. Oh, man. Just stick that, I need to pin that right there, okay? Then, the mass number is equal to number of protons and number of neutrons added together. That would be 23. Okay? So now, let's row 1 done. Number of protons we know, so we know number of electrons. We also know the atomic number. All right, so now we are a little backwards this time. We know the mass number and we know the number of protons. We don't know the number of neutrons. So what we do, we take the number of the mass number here, 31, and we subtract the number of protons. So 31 minus 15 gives us 16. So then here on cobalt, the third one down, we're given 27 protons. So therefore we have 27 electrons. Therefore, the atomic number is also 27. The mass number is equivalent to the number of protons and neutrons added together. So which would be 27 plus 32. That would give us 59. All right, so just about done here. Now with bromine, we're given the number of electrons. So that's equal to the number of protons and the atomic number. Now we have to do this backwards again. The mass number is equivalent to protons and neutrons added together. So we don't have neutrons though. We have to take 80 and subtract the number of protons, which is 35, to get the number of neutrons, which is 45. And silver, we're given the atomic number right here. So there we can find out number of protons because it's the same number, and the number of electrons. Next, we don't have the mass number. Mass number is number of neutrons plus number of protons. 47 plus 61 is 108. And there we go. And that's your answer. So, any questions on that? I'll give you a second. Any questions? All right, if not, I'm gonna move on. I had to change pen because I ran out of ink, I guess. So number 28 here. Element X has two naturally occurring isotopes, X79, with its abundance being 50.69% and its mass being 78.918 AMUs, and then X81, which abundance of 49.31% and mass of 80.917 AMUs. What we have to do, we have to calculate the atomic mass that's weighted of X, and also identify the unknown element. It is a real element. So, oh, my camera's pointed a little too far down there. So what we have to do, we have to take a weighted average here. So what does that mean? Weighted average means you have to take the mass here, multiply it by the percent, and then you have to do that for the rest of the elements as well. So this would be mass of 1, percent abundance of 1, plus mass of 2 times percent abundance of 2. This is just kind of a generalization. So let's go mass of 1, which would be, let's say, X79. We are 78.918 times percent abundance. Whenever we use a percent in a mathematical formula, we have to convert it to a decimal place. How you do that? You move the decimal point here 2 places to the left. So that would be 0.5069. Then plus mass of number 2 here, which is 80.917 times 0.4931. Then whenever you solve this, whenever you type this into your calculator, using parentheses, by the way, you will get an answer roughly of 79.904 AMUs. That's one answer. The second answer is you have to look at the the periodic table and find what element has this mass. When you do that, that would be the element bromine. And that is your complete answer. For number 29, calculate the number of protons, electrons, and neutrons here in an atom of the element Pb, that is lead, with mass number 207 and atomic number 82. So we need to know number of protons, electrons, and neutrons. So we're given atomic number and we're given mass number. Atomic number is 82. Mass is 207. So if you look back up at problem 27 here, we know if we're given the atomic number, that is equal to the number of protons as well as the number of electrons. So our atomic number is 82. So we have 82 protons and 82 electrons. Pretty simple there. Then we know back up here at 27, the mass number is equal to number of protons plus number of neutrons. Well, in this case, we have the mass number and the number of protons. So take 207, subtract 82 from it, and you're left with 125. That is your answer for number of neutrons. All right. So here comes a tricky one. Number 29. Basically, calculate the mass in grams for 7 atoms of manganese with an atomic number of 25 and a mass number 55. So we need to figure out how many protons and neutrons are in this. 30. This is some math. So we're given 7 atoms of Mn, atomic number of 25. Mass number 55. All right. So, number of protons here. P plus is going to stand for protons. Is 25. That's the atomic number. Number of neutrons is 55 minus 25 here. That is 30. Next, I'm going to give you a general formula again. So we need to find out the mass of these 7 atoms. So I'm going to give you 7 atoms here. Then we're going to add, or not add, but we're going to multiply. We have 25 protons, so P plus, times the mass of a proton, which is 1.007 Oh man, I looked at the wrong problem. We need grams. I'll rewrite this. 7 times 25 P plus times, I'll make sure to get the right number this time, 1.673 times 10 to the negative 24th. That's the total number of protons. I'm going to put a second set of parentheses here. 7 plus, then how many neutrons we have? That's 30. Times, then now the mass of a neutron. 1.675 times 10 to the negative 24th. So when you do all of this math together, what you will get, you will come up with an answer probably of 6.4453 times 10 to the negative 22nd grams. Or you may have it as 644.53 times 10 to the negative 24th. And that is number 30. Man, that's a lot. So next, number 31. Fluorine contains 9 protons and 10 neutrons. Calculate its mass for 81 atoms. Man, that did not go easy. So, what we can do, I'll break out the calculator real quick. Maybe you can see that, maybe you can't. Okay, if I put it there, you can. We're going to find the mass of 81 atoms. So we know one fluorine atom has 9 protons. 9 protons here. And based off of what we're given here, one proton has a mass in AMUs of 1.007276. Then we know we have 10 neutrons here. And it has a mass of 1.008665 AMUs. I didn't write my units. If we were to solve this right now, 9 protons weigh this much, and you add 10 protons that weigh this much together, you get the mass of one atom. If we take all that and times it by 81, you get the mass of 81 atoms. So say we do that. That gets us 1,551.32 AMUs. And that is your answer for 31. And then number 32 here. Oh, not 33, 32. How about that? Didn't need the calculator over there. Ah, yes, equal to 3 tons. Lead contains 82 protons and 125 neutrons. Write the shortened notation of the element with its symbol, atomic number, and mass number. So if you rewind back up to problem, what was it, 24? You have mass, atomic mass up here. Atomic number down here. And then you have element symbol over here. So in the problem we're given 82 protons and 125 neutrons. Well, 82 protons, that is our atomic number. So 82 goes on the bottom here. So the atomic mass is the number of protons and neutrons added together. So 125 plus 82 is 207. And then we just need our element symbol. For lead, it is Pb. And that is your answer. So there is your chapter 4 study guide. So at that point in time, you have everything. I can turn it over and basically show on paper all of the answers again in case you didn't get them. All right, so there's 1 through 24. And then there is 25 through 31. Or sorry, 32. Way at the bottom. I will upload this as well to YouTube. Same username as on here, the_chemist. So that way it will be saved there. It'll be up in probably roughly 20 minutes. So, all right, study and come prepared to take your test tomorrow.